All right, so we're going to be going through the nature of the roots and the discriminant of the quadratic formula. So, what do the roots of a quadratic equation tell us about the graph of the parabola? Well, they're going to tell us where it crosses the x-axis. And the thing that determines what type of roots we get is the discriminant. So the discriminant is the part of the quadratic equation that's under the radical sign. So if you remember, it's x equals negative b plus or minus the square root. So b squared minus 4ac is called the discriminant. B squared minus 4ac, that's the discriminant. So we're going to be dealing with just that small piece of the quadratic formula right now. So we're going to fill in this table. So there's a couple different things that can happen. Our discriminant can either be positive, it can either be positive we're going to skip one, go down here, it can be 0, or it can be negative. Okay, so if it is positive, it can be positive and it can be a perfect square. Or it can be positive and not a perfect square. So those are the four things that can happen. We're going to talk right now about what they do to the roots and what the graph is going to look like. So if it's positive and it's a perfect square, it means that the roots are going to be real. There won't be any i's in them. And rational. Okay? If it is a perfect square, it means that they're going to be unequal. So you're going to have two of them. So I'm going to change colors here. There's going to be two roots here. The graph is going to touch the axis twice. And it's going to look something like this. So your graph is either going to go up or down, but either way it's going to go through the axis twice. So it could look like this, or it could look like this. Either way, it's a U or it's an N, but it's going to hit twice. If it's not a perfect square, it's still going to be real numbers, but now it's going to be irrational. And again, they're going to be unequal because you're doing plus or minus. So there's going to be one that's something plus something, one is going to be something minus something, so they will not be equal. So you are still going to have two different roots here. The graph is still going to touch twice. So again, it's going to either be a U or an N. It's going to come down and through like that, or like this, or like this. Whatever it looks like, it's going to go through the axis two times. If the part under the radical there, the discriminant, b squared minus 4ac, if that is 0, now this is something a little different. You're going to have a real and rational answer, and they are going to be equal now. Because it doesn't matter if you add 0 to something or subtract 0 from it, you're going to get the same answer. So in this case, there's only one root. What this means is that the graph touches once. So if you have your graph, it's going to come down here, it's going to touch that axis and come back up. So it only hits one time, right at the vertex. At the vertex, it hits once. The last thing, if what you get for the discriminant is a negative, it means you have a negative under the square root. So it is going to be imaginary. If you have an imaginary root, it doesn't intersect the x-axis at all. So this would be one of the parabolas that if you have it here, it's going to come down like this, and it never hits that x-axis. It never comes down and touches it. Okay? Or it could be one that comes from the bottom up, like this, but again, it never comes through and hits the x-axis, so there are no roots for it. So what does this look like in the context of a problem? If we want to describe the roots of 2x squared plus 6x plus 3, you want to take a similar approach as we did before. So you want to know what is A, what is B, and what is C. A in this case is 2, B in this case is 6, C in this case is 3. But instead of doing the whole thing, the whole quadratic formula, we just want to do B squared minus 4AC. So B in this case is 6, so 6 squared minus 4, A is 2, C is 3. So we're going to have 36 minus 4 times 2 is 12, times 3 is 36. So in this case, the discriminant is 0. We need to know, what does that mean? If the discriminant is 0, it means our roots are real, rational, and equal. Real, rational, and equal. So that is what your answer would be. Doesn't matter what they are exactly. They didn't ask. They just said up here, they just want you to describe the roots. Tell me what they're going to be like. Example number 2. Find the value of k for which the roots of the equation 2x squared plus 7x plus k are real. So, we again want to know what is A, what is B, what is C. A in this case is 2, B is 7, and C here is actually going to be a variable still. It's going to be k. So we want to know, when are the roots real? Well, for roots to be real, the discriminant, b squared minus 4ac, has to be greater than or equal to 0. When it goes less than 0, it turns into a negative, and that's when the roots become imaginary. So we need it to be greater than or equal to 0. So we're going to go ahead and plug in. B is 7, so 7 squared minus 4. A is 2. And C is k now. And we want this to be greater than or equal to 0. So 49 minus 8k is greater than or equal to 0. We're going to solve this just like any other inequality. Minus 49 minus 49. And you'll have negative 8k is greater than or equal to negative 49. The last thing you want to do is divide both sides by negative 8. But you have to remember, with inequalities, when you multiply or divide by a negative, this inequality symbol here has to flip over. So we are now going to have less than or equal to 49 over 8. It doesn't work out any nicer than that. It can't be reduced, so that is our answer. K has to be less than or equal to 49 over 8 for the roots of that inequality, or for that quadratic, to be real. We're going to do the first one here. I want you to try the other 3 on your own, and we'll go over them in class tomorrow. So for example 3 here, they're saying use just the discriminant, which is b squared minus 4ac. So we want to use b squared minus 4ac, and we want to figure out, are the roots of this real, rational, and equal? So if they are real, rational, and equal, this is going to be 0. Real, rational, and unequal is going to be positive and a perfect square. Real, rational, unequal, real, irrational, and unequal is going to be positive but not a perfect square. And imaginary means it's going to be a negative number. So we need to figure out, is it A, B, C, or D? Well, in this case, we know that A is 1, B is 2, and C is 1. So b squared minus 4ac is going to be 2 squared minus 4. A is 1, and C is 1. So 2 squared is 4 minus 4 times 1 times 1 is 4. 4 minus 4 is 0. Well, if we are at 0, we know that the roots are going to be real, rational, and equal. So that would be choice A. Okay? I'd like you to figure out, for the next 3 examples, just do b squared minus 4ac for each one. B squared minus 4ac, that is the discriminant. B squared minus 4ac for each one of those. And figure out, are the roots going to be equal, unequal and rational, unequal and irrational, or are they going to be imaginary? So go ahead and give that a try tonight. We'll go over it tomorrow during class. If I forget, you need to remind me, please. Other than that, have a wonderful evening.